Everybody, I'm Dr. Daniel, and we're going to talk a little bit today about an experiment that we did. I'm calling it the Quince experiment. And what we're doing is we're trying to prove a hypothesis, which is basically an idea, whether something works or not work. So basically what we're doing is we're trying to formulate an experiment that will tell us whether something that we're thinking about will actually does what it does. So how we did that, first of all, the idea was that we have a gel that we have, and that gel does help with cell signaling, as well with cell function, as well as with cell staying natural as much as possible. So for us to do that, it does this on any cell, basically, by the way. For us to do that, we had to devise an experiment that takes away some of the factors that may give us wrong information. So for us to do that as well, we chose plant cells. Plant cells are cells just like human cells, but they're a little different. Because they have a cell wall rather than a cell membrane. But basically what I'm trying to say is those cells have the same functions like a human cell. So we chose plants because plants don't have any placebo effect. Humans do. Animals don't have it, but we cannot gauge it sometimes. So plants are something that we can try and actually control. So we chose them because of that. We chose them because of the placebo effect, and we chose them because we can manipulate and do whatever we want to do with it and see what the results are, So we reduce a lot of the factors and the things that we can say, oh, I wish I've done that, or wish I've done that, or whatever. Now, what we chose though is a fruit that we can see a difference in. We tried, I don't know if you've ever cut an apple or something like that, but every while you see that the apple becomes brown. Well, why does it do that? Because there's a lot of iron in it, and iron actually oxidizes. Well, I guess human beings have iron in them, in our blood, and that oxidizes too. So we live, and it's called perspiration. So plant cells do the same thing. They perspire, and they have chloroform that does that. But some plants have also iron in them. So if you think about it, a plant cell, fruit of some sort that has high iron content will change color. So apples do that. Actually, a lot of different kinds of apples do that. Some don't, some do. So we chose one that actually did not do anything, and we chose one that's called the Quince. A Quince is a palm, so it is an apple, but in a sense, it's not really, it's actually a pear, kind of like a pear tree, but it is a little different. It's a little tart and so on and so forth. But when you cut up Quince, it changes color right away. I mean, not right away, it takes a few minutes, but then it changes color. And that changing color is basically the oxidation of those cells, and they basically from there are desiccating and becoming less and less alive. So what we did is we took we sliced four slices. One we did nothing with. The other one, half of it, on one side, we did only the one gel, and the other side we didn't do anything, so we left it open again. And then the second one next to it, we did one side with only the gel, and the other side we didn't do anything. And the fourth one, we did the same thing again. We sliced only half of it, not the other side. I mean, not sliced, but actually put the gel only on one side. And we also reduced our possibility of problems by changing the error by actually reducing what kind of gel we're using. So the one gel that we wanted to experiment was the first one that we did, but then the second gel was just over-the-counter something that has a gel in it that's an anti-inflammatory gel that you can buy anywhere. And we also chose another one that's like another gel as well. You're welcome to text me later if you ever want to know the different gels that we used. so as you'd know what I did. But what we done is we used the first gel and we put it on there, second gel, third gel, all at the same time. So we eliminated time difference by having all of them at the same time. We cut the apples as well as the Quince all at the same time. We put them all together, and I'm going to show you all that in the experiment as we go along. Now, I also want you to know that we also were thinking, okay, what can we do that people can do on their own? So you can actually get a Quince and do it on your own, try it out, and see how that works out for you. I'd like to know what your experiment looked like and what your results are. It's a really interesting experiment. So try it out. It's very simple to do. Anyway, there is some information later. If you are interested in more information, by all means call me and or text me on the side or send me a message or something. I'll be more than happy to tell you more about this. And let's get this experiment a little more oomph by having it more and more people doing it, and see what the results are for you for what you've done. I'd love to see that. So text me and or send me. As I said, I'll be more than happy to see it. Good to see you guys. Talk to me again. Thank you. Another experiment. We're cutting a piece of apple, and as you can see, there's the apple. And we're putting it into 4 different categories. We're going to let it be for a few seconds, and we're going to start putting different gels on there with different concentrations. Let's see what happens. So here we are after about an hour or so now, and we're looking at the different apples and Quince that we have, and you can definitely tell that there is a change in this one between the one half and the other half, compared to nothing, compared to dreliecdaniel, and compared to the other gel that we put up there. And again, this is the apple. On the apple, we cannot tell very much. There's a little bit of a change, but the Quince is definitely a difference between the two. This is very, very important. Now we're concentrating on the one that we're working on. It's been 3:35 right now, and you can see a little bit of change happening to the side that we put on, but there is definite demarcation between the side that we put on and the side we did not put on. You can see here there's like a line right there, that line right here, and a line right here. That's where the area we put it on, right here. This area we did not put nothing, and this one we didn't put nothing on it. And that's on the Quince fruit that we are using for experimentation. As I'm looking at this Quince slice that we're experimenting on, you can see that the one side there has desiccated on the one side, and on the other side there still is a bit plump, and definitely a difference between the color of the one side versus the other side. It still is working, it seems like. We put it on 11 in the morning. It's about 5 right now in the evening. So it's been almost 12, 1, 2, 3, 4, 5, 6, almost 4 hours, 5 hours that we have put this on. And it still is lasting. I'm gonna keep this on. Let's see how this works for tomorrow. We'll see how it works. So now this is the second day, and it's 9:56 in the morning. And again, this is the nothing. This is the one we did with the half gel, half nothing. And you can see the difference between the half and half, what's going on. Also the thinness of the one side and the thickness on the other side. Also, if I touch it, it's nice and plump here. Over here is desiccated. It's very desiccated. Here I cannot bend very much. It's not bendable. Over here it's very bendable. Very bendable. You know, it could be the thickness, it could be anything. Like this one here though, it's not bendable, but it is a very thick layer we started with. So we really need more controls, you know, of this. But at least it's just a crude experiment as to what we're doing. It just proves that we need to have more controlled experiments, and I think we will get some good results as well. This is the back side of it, and again, you can definitely see here different than this here. This is the layer we did the gel, this here we didn't. So apparently it penetrated through all the way down to the other side. We only did the one side, and you can see it's much better also on the other side too. So